Hi, so in this video I want to talk a little bit about the wrapt library. This is a really super useful library for easily writing decorators and kind of more advanced functionality decorators in Python. Now of course we can always do that in plain Python, but this wrapt library makes certain things much easier. And I'm going to show you some of those things in this video, but it does have a lot more functionality that I encourage you to try and just read the documentation and see what's going on. So if you find yourself writing a lot of decorators, or maybe even just a few, you ought to give this library a try. It's actually very easy to get started with, and in the longer term you can increase your utilization of it as you learn its more advanced functionality. So let's see how we would use this library to write a simple decorator to maybe log function calls. And I'll show you how we would do all this using plain Python, and then we'll contrast this with how it works when we use the wrapt library. So I'm going to write something to basically log function calls. And in this case, I'm actually going to want to actually do logging. Usually, if you've seen my videos, I just do a print statement. Here, I actually want to set up logging, and I want the logs to show up in my Jupyter notebook. So I'm going to have to do a little bit of work here first. And it's more just, setup work to get the logger to work with Jupyter notebooks. So the first thing is I'm going to create a handler, and I'm just going to copy paste this code from the notebook. As usual, the code is available in the repo, which is linked below the video. So I'm going to set up a stream handler. Then I'm going to set up a formatter. Now this formatter, I'm going to want to output the ASCII time, the level name, like, info, debug, those kinds of things, and then the message. And then furthermore, I want to specify how I want to format my time. So I want year, month, day, hours, minutes, and seconds. And then this style here is just because I prefer using curly braces to using that percentage, then open paren, then put in ASCII time, close paren, S, that kind of rigmarole that we have to do, kind of the older style of doing that. And then I'm going to set this formatter to this handler that I just created. So that's the handler created. Now, if you're curious about the attributes that I use in the formatter, in the notebook that I have linked below, I have a link to the specific page in the Python docs that tells you all the possible things you have available that are kind of built in for this formatter. Okay, so now what we need to do, because Jupyter, when it starts up, it actually creates a logger, right? So there's a root logger already created. So it's not like when you start a plain Python app with, an app that you wrote and you just run it from the command line, let's say, then you can set up your root logger and everything's a little bit easier. Here, Jupyter's already done that. So we're going to need to basically add this new handler to the existing root logger. So we're going to do this. We're going to say logging.get logger. So we're going to get our root logger, and then we're going to add the handler, like so. Now we need to get the logger for this particular notebook, because this particular notebook has its logger. So in order to do that, we're going to say logger equals logging.get logger. And we need to pass it the name of this module, which is just the dunder name. And then while we're at it, we're also going to set the level. So I'm going to set this to debug level, like so. Now we can also view the logs. So if we go to show log console here under the view menu, and if it's not set to debug, just go ahead and set this level to debug here so we can see those logs as well. So we'll say logger.critical, and this is a test, like so. And so you can see that now I do see this log event right here in my Jupyter output, in my Jupyter notebook. It's also here in this log over here. So I'm not going to worry about this one. I've basically set this up so we can get our logging right here. Okay. So that's done. So now let's look at the standard decorator approach. So I'm not going to waste time typing it in. I'm going to copy this back from the notebook. And here's our function, right? So this is our decorator function. It's called log. I use wraps. Remember, this is best practice. We use wraps so that it carries over things like the function signature, things like the function documentation string, if there is one, the doc string, and a few other things that it kind of cleans up for us. So now let's go ahead and create a decorated function. So I'm going to basically decorate this add function, which does nothing more than just add two, positional arguments, and then, however, it decorates it with this log. So now I can go ahead and say add 1, 2, and you'll see that we get our info, because if you look at my decorator, in the decorator, if everything ran okay, I output an info saying that this function was called with these arguments, args and quogs. And if I wanted to, I could put in the function name as well over here. I didn't bother doing that, but we probably should to identify which function, right? So you'd say something like this, like fn name, like so, right? Called with. And then we'd want to do the same thing here for the error message. And let's run this again. And now you can see that add was called. Maybe we should say, I don't know, what should we do to make it stand out? We could say func, maybe we'll put square brackets around it, like so. Okay, so we could do something like this if we wanted to know the name of the function as well, which is probably a good thing. Okay, so the add function was called with that. Now, what about an exception? Let's make sure that we get an exception. Info message, an exception error in our log, I should say, not in info, but an error. And let's go ahead and add A, we'll add the string A to the integer 1, which we know that should fail. So except, and I want to make sure that the exception was raised. So we'll go ahead and just print the exception here. And because if you look at what happens with the exception, right, the exception handler in this decorator, I log and then I re-raise the exception. So I'm not silencing the exception, I'm re-raising it. So here, with this decorated function, when I run this, I expect to see this log being written out to the log, which means we should see a line similar to this. And we should also get an exception being raised. And this is what we should trap over here. So maybe I'll put in a few styles like this, just so we can differentiate, between this error message that's going to be logged here and this exception message that's being displayed here. So you can see we get our log message, and we also did get the exception, right? And of course, the exception message is the same. Now, maybe we want to silence the exceptions. Just log the exception, return none, and continue. But we don't always want that, right? We want the option to say, well, I don't want to, with this decorated function, if it raises an exception, I don't want the exception to be raised in my code. I just want it to be logged and silenced. But sometimes I may not want to do that. So I need to basically now bring in a variable, right? That's going to control whether we have silence thing or not. So for this, of course, as you should know by now from my other videos in this channel and in my courses, we need to write a decorator factory. And this is what the factory looks like, right? We're going to have this log. This is going to essentially create a decorator, but we're going to pass it now this variable optionally called silence. And now our decorator is very much like before, except that I now check this silence, right? Which is a part of the closure here. So if I don't have silence, then go ahead and raise the exception. Otherwise, it does nothing, which means it has silenced the exception. So this is how we would do that. So now we have to call log. We can pass in silence. It's optional. Now, this is a log decorator. It does need to be called. There are ways that you can get around this so that you don't have to put in those empty parentheses. I've done a video on that if you want to look in this channel. But over here, I'm not going to worry about that. And I'm just going to basically have to specify it as a callable, whether I pass a value or not to the decorator factory. So now I've decorated this function. If I go ahead and add, I get the same thing as before. But now the difference is, let me go back and let's just copy this code over here. We're going to force an exception. And you'll see that it's just like before, right? We get the log of the exception and the exception was raised. So now let's change this and let's say silence equals true. And so we're going to do that. We're going to recreate a decorated function, and let's do that. And then let's call it again, like so. Because when I copy pasted, I did this. That was stupid of me. I just want this as the decorated function. So let's go ahead and do that again. Let's try it. And now you can see that indeed we did not get an exception. So the exception was logged and silenced. All right, so these are the two things that we did, right? We have essentially now this decorator factory. It can take a parameter to silence the exception or not. So now let's switch to using wrapped. And let's first of all import it. And I'll show you also a few other things with the introspection that you gain by using wrapped that you don't get even using wraps, right? The wraps that we saw earlier. Even using that, there are certain things that aren't quite handled correctly that wrapped will actually also do for us. So let's first start by rewriting the decorator that we had, right? So remember the decorator that we had, the initial one. Let's do the simple one first, which was just the plain decorator. So it was this one. Let me just go ahead and paste it down here, like so. So this is the code that we have. Now, to rewrite this using the wrapped decorator, the wrapped library, we're going to use wrapped.decorator. So we're going to use a decorator to essentially create this decorator. Our decorator is called log. Now, when you use the wrapped decorator, there are two initial arguments that are required whenever you write this decorator function, right? This log decorator right now that I'm writing. So the function signature is basically always the same. You have the function itself that you're going to be decorating. You have this thing called instance, and this is because decorator can also be used, and I'm not going to cover that in this video, but it can also be used to decorate things like properties and static methods, and not properties, instance methods and static methods, class methods, all that kind of stuff. So in that case, if you're decorating an instance method, this is going to give you access to the instance, right, of the decorated instance method that's running. Now, in this case, we're not using that, so it's not going to matter. But however, the arguments are always the same. We also need args and quargs, the keyword arguments. Now, you can name these things whatever you want, right? I think the documentation for wrapped, I think, calls this wrapped. I like to call it FN because I've used FN just now in my example, and I want to keep that consistent. Now, the one difference here, you do not specify star args and star KW args. Do not specify that. It is just specified as a regular positional argument. You can again name it what you want, but it's customary to use args and KW args or quargs. Okay, so now we need to do basically the code that we had before. I'm just going to take this code and I'm going to paste that right in. So I'm not even going to retype anything. I just need to fix the indentation. And that's it, right? That's all we need to do when we use the wrapped library. So you'll notice that we don't have a nested function that has to be returned. This is being taken care of by the wrapped decorator. So it's just basically a single level saying, hey, I want to create a decorator. It's going to decorate this function, and the function is going to receive positional arguments and keyword arguments. So now I'm free to call this function with the arguments. Now, of course, those are positional arguments. I need to make them. This is just going to be a list. So I need to expand that. So it's a star args now in this case. This is going to be a dictionary. So I need to basically, again, expand this dictionary into keyword arguments. So that's the star. That's what that does. And then I just do the same thing as before. So nothing has changed, right? Everything is the same, except we don't have this inner, and we don't have to use wraps because we're using wrapped, and it's going to take care of this piece of functionality also for us. So as you can see, it's a little simpler to write decorators. So let's go ahead and try it out. So I'm going to basically do the same thing as before. We're going to log, the name of the decorator is still log, and we're going to add A and B, right? And so I can say add 1, 2. Let's make sure this works. Indeed, we get the result 3, and we also get the log itself. Now let's go ahead and try, but now with an exception. Let's see what happens. It should behave the same way as before. We're going to add the string to an integer. That's going to fail. We should see the error, and we should see an exception being raised. And indeed, that's exactly what happened, right? We see the error logged, and we actually have the exception that was raised as well. So now let's go to the second kind of variant that we had, which is where we had this silence. So again, let's go back to what it was. And it was over here. Okay, so this is what we had. This was our decorator factory now. And we had, therefore, the decorator itself, right? So we have the decorator log, which is the factory. It's going to actually create a decorator and then return it. And then the decorator was kind of what we had before. So this was the plain Python code. So now, using wrapt, we would do it this way. So again, I'm not going to waste time typing it out. Here we go. So again, we do need the decorator factory. But how do we create decorators using wrapt? We just use this wrapped decorator, right? So I don't need to write this over here, this def decorator, return decorator. I still have to do the factory. So my log isn't the actual decorator, so it's not being decorated. The inner function is being decorated, and then I have to return inner. But as you can see, instead of having, 3 nested functions, now we only have 2. But nothing's really changed. It's the same as before, except this simplifies the creation of a decorator, the definition of a decorator, a little bit. So now, if we go ahead and we can say log, and again, this is the one now that requires a parameter. Since silence is defaulted to false, I'm going to keep that. I don't want to silence this one. And then I'm going to add my regular add function, like so. So now that I've decorated this, I should be able to add 1 and 2, no issues. And then if I try to do with an exception, now I should see the exception, right? So we get the log and we get the exception because silence was indeed false, because that was the default. So now let's go ahead and change that. And let's say silence equals true. And let's go ahead and now run this one again. And now in this case, indeed, we get the expected behavior. We get the logging error, but we do not, or we get the error log, I should say, but we do not get the exception. Okay, so this kind of shows you how to use wrapt to create decorators. Very, very similar to how we do it in Python. It just simplifies things a little bit. It removes essentially one level of nesting, with the functions. And some people find that confusing. But I want to get on to some of the more advanced features of this library. And this one is particularly useful. It's a way of enabling and disabling the decorators. So I've got a decorated function, and I want the ability to either enable or disable that decorator without having to rewrite my code. Now, the circumstances where that could happen, well, it could be, for example, when you start your Python app, you might have an argument that says disable logging decorators. And you'd have, a variable somewhere that's going to, hold that value to false. And then the decorator, when it's decorating your functions that are being logged with this, or decorated with this logging decorator, you want to make it basically go away. It shouldn't do its stuff, right? Do its stuff was what? Well, call logger info, trap the exception, if the logger error, do the logger error, and then depending on silence, raise or not. Let's say I want to disable all that by just passing a flag into the app. And if I pass it to false, I want to just basically run this. Otherwise, if I set to true, then I want to run the whole decorator, right? Now, you can certainly do that in plain Python, but it's not easy. You're going to have to write a certain amount of code to do that, right? And I'm not even going to attempt it here. But by all means, try it on your own. But instead here, we're going to use the wrapt's built-in functionality to do so. So let's start off by supposing that we have some module-level variable. Maybe it comes from the command line argument. Maybe it's being read from a config file. Maybe it's being read dynamically from a an API call. We'll get to that later. For now, let's suppose that it's a one-time variable, global variable, that's being set either when the app starts or from a config, right? When the app starts. So when the app starts with a command line argument or from a config. So let's go ahead and let's call it log enabled. And I'll just say log enabled equals true. So I'm going to take our original decorator here. I'm going to paste it down here. And all I need to do here is specify the enabled argument to be true or false. Now I'm going to grab it from the log enabled variable over here, like so. Now keep in mind what happened here when I executed this cell. It compiled the log, right, function. This was an actual value. Log enabled is true, right? This was this global variable. Now I'm going to decorate a function, but if I want to change log enabled, then using this log function over here isn't going to disable the log if I just change log enabled to false. It's already been done, right? So if I go ahead and say log and then def, and of course I need to pass in no arguments, but it is a callable now because it's a factory function. It's a decorator factory. And we'll just say add, and then we'll return a plus b, like so, okay? Now, this is all fine. If I go ahead and say add 1, 2, you can see I get the log. Now, if I was to say log enabled equals false, and this is what I was trying to explain just now, and if I try and say add 1, 2, you'll notice that I still get the log. And so it didn't honor this log enabled equals false. Well, yeah, because this function was decorated. So what happened? I called log. It basically returned this over here, right? And it used this decorator with log enabled, with whatever it was at the time. So this is now fixed. Changing this after the fact doesn't change what happened here. So in order for this to work properly, I have to rerun this code to redecorate my function. Now, when you're using this functionality, when your application starts up, it's going to read log enabled, let's say from the command line or from a config file, and then it's going to run and do all the other stuff, right? It's going to run your code that decorates functions and so on. And in particular, it's going to run this particular code over here and this particular code over here. So every time your app restarts, whatever this is set to will work, right? This is only because we're in a Jupyter notebook. We're not restarting anything, right? So this is why. But it also means that as your code is running, you cannot use this technique to selectively turn on and off your particular decorator or this logging decorator, right? Because you could think that maybe I have an API call that I check once in a while to see, do I want to, still emit logs or not? And maybe at some point the API, which started off saying yes, true, at some point it starts returning false values saying, no, don't stop logging, for some reason or other. Well, using this technique, that's not going to work. You can make it work, and I'll show you that in a sec. So the point is that we need to rerun our decorator. Now, if we go ahead and add 1, 2, you'll see that it now behaves just like the original undecorated add function. Nothing else is happening. So this is something that would actually take quite a bit of work to do with Python. But now, what if we do want it to be dynamic while our application is running? I mentioned, an example of why we might want to do that. Well, wrapt actually has that covered as well. And all we need to do is that instead of specifying a Boolean value here, we specify a callable. And the return of the callable is going to then dictate whether this is going to basically decorate the function or not, whether the decorator is going to be enabled or disabled. So let's go ahead and do that. And I'm actually just going to use a lambda function. So again, I'm just going to use the global variable to affect things. So we'll say log enabled equals true. We'll start off with true. And then here, I do not want an actual static value. I want a function. And all that function is going to do is that it's going to return this log-enabled value global variable. But as I said, it could be looking into a database or making an API call or whatever it is that's controlling that value, right? So it could be a function that does something totally different. Here, I'm just going to do a simple lambda function, and it's just going to return whatever the current value is for log-enabled. Now, because this is a callable, right, the value, the static value, true or false, isn't getting baked in to our decorator. It's just a callable. At the time when the decorated function runs, then, not when it's being decorated, when the decorated function is called, at that time, this will get evaluated. So let's go ahead and try this. So let's do that. And let's again just create our decorated function this way. And maybe just to change things up, let's say silence equals true. So now if I add 1, 2, you'll see that I indeed get my log record over here. Now let me go ahead and change log enabled. Is it log enabled? Let me just copy this. See, this is why I don't like having such big fonts, because by the time I'm here, I can no longer see, what I had over here. All right, so log enabled equals true. I'm not redecorating the function. My code, my application hasn't restarted. I've just changed the value that this lambda function is going to return, right? And now I'm going to say add 1, 2. And of course, I need to disable the log, right? So let's disable the log and then run the function. And you'll see no logging. So the decorator was disabled, and this was dynamic, right? So these are the kinds of things that this wrapt library gives us. This kind of more advanced functionality, and also very easy to do so, right? You would have to write quite a bit of Python code to achieve something like that. Now, the other thing too that I want to touch on just very briefly here is the introspection. Under the hood, wrapt with a T also provides much better support for introspection, much better support than the Python wraps itself, right? So let's go back to a basic Python decorator just to show you that. So we'll do this decorator, right? It just basically does nothing. It's like a pass-through decorator. Essentially, it's just going to call the decorated function with the arguments and keyword arguments, and that's it, right? So now let's go ahead and write my dec. And so I'm going to decorate this function called add, and we'll add a, b, and then I'll put in maybe extras, and I'll set a default to none. This is just bogus stuff, right? And in fact, let me just copy this from the notebook. I don't want to retype this. So I've got a doc string, right? So this function adds 2 objects. The extras is just basically junk just to add it in. So we have some keyword arguments here. Okay, so it works just as before, right? We can do add 1, 2, we get that, and so on. Now, if we do help on add, then we're going to get something a little bit different. What's happening is that when we get help for add, it's really saying, well, this is the inner function. Well, that's true because this is our decorated function. Add has been decorated. What are we actually calling? We're calling inner. So this is correct. And this is why we end up in plain Python by using wraps. So we say wraps fn. And in my deep dive course, I actually show how to do all this without using wraps. I kind of show you what wraps does behind the scenes. And now we need to decorate our function. So I'm just going to take this code, recreate it. Now add works just like before. But now if I do help add, you'll see that I get the correct thing. I get the correct name of the function, I get the correct arguments shown here, and I get the correct doc string. So wraps does that, and wrapped will actually also do that as well. But let's go a step further. Let's look at the inspect module. Import inspect. And with inspect, we can get doc. So we can get the documentation string for a function. If we do that, we used wraps, so we get the correct documentation string. That's great. What about inspecting code and arguments? The inspect can also do that. So we can go ahead and say print inspect get source of add, get the source code for add, and it brings it back correctly. It says, hey, this is what you have over here. That's correct. So wraps kind of took care of those things. But one of the things that it hasn't taken care of is when we do an inspect with the get full arg spec, right? That's one of the things. So when we do that, you can see that, well, our arguments are missing, right? There's no arguments, there's no keyword only arguments, there's no defaults. Well, our add function has some of these, right? So obviously this isn't picking up the right thing. What is it picking up? Well, it's picking up this args and quags over here. Where is it picking that up from? It's picking it up from inner. It's picking it up from this over here, right? So this is one of the things that wraps doesn't quite get right, but wrapped does, right? So let's go ahead and do an example with wrapped. So again, I'm going to do a plain kind of pass-through decorator, but now using wrapped. So the equivalent is basically to say, okay, I've got wrapped decorator. Again, my signature here doesn't change. And then I'm going to return function args quag. So it's just a pass-through, just like our regular plain decorator was. And now I'm going to use my deck to decorate my function again. So let me copy paste that, right? So now this is using the wrapped decorator that we just built. Again, it works just fine. If we add 1 and 2, we get that. If we get help on add, we get the correct thing as well. But wraps was doing that anyways, so we're not gaining anything here. And we can do also the print inspect get source. So we can do that. We can get the docs. All that is going to work just fine, right? This hasn't changed. But now if we get this one, if we do the, where is it? This one. The full arg spec, you can see now that this is for the add function, for the original add function that we ended up decorating, right? So wraps didn't get that one quite right. Wrapped does. Okay, so this is just a few of the things that you can do with the wrapped library. It's got quite a few number of other tricks up its sleeve, including straightforward ways to decorate class instance methods, class methods, static methods, and even decorating classes themselves. So go ahead and give the wrapped library a try. I guarantee that you're going to like it. All right, thanks for watching.